Hi guys, Mrs. Kelly here. So now we're in section 7.4, sum and difference formulas of sine and cosine. And I think I'm going to give you the tangent, but you won't have to do it. We're only doing certain things from each section for time's sake and for sanity's sake, okay? So in this box are the sum and difference formulas for sine and cosine. Okay, please make sure you put them in your notes. This little guy is your alpha, so you'll hear me say that. And then this guy is your beta. So just sticking with some Greek letters. You're used to theta. It's all the same thing. You'll see if you look online, you'll see the letter A or the letter B. It all means the same thing because it's just representing an angle. Okay. So sine, your sum formula for your sine and cosine. Notice the difference. Like the sine, it's sine of alpha cosine beta plus cosine alpha sine beta. So kind of switch it, sine and cosine. But the cosine sum and difference stay all cosine and then all sine. Same thing with the difference, cosine, then sine. And then the sine's just a little bit tricky. You should, right now you can use your notes because I can't tell, but you want to be able to memorize these, especially for calculus next year, okay? So we're going to start with example 1. This is right from your book again. So page 467. It says find the exact value of cosine of 75. So you could 100% put it right in your calculator, get cosine 75 degrees, but we're not going to do that. We are going to, no, I lied. You don't have to memorize this. Let me get rid of that. It's good to know them though. So I'll get rid of that. Don't worry about that. All right, so find the exact value. So if you break up, I put the unit circle here because you're used to easy angle measures. So like 30, 45, and 60. You can break up 75 degrees. Okay, so we're going to call 75 degrees instead. We're going to say that's the cosine of 45 degrees plus 30 degrees because these are easy angle measures that we can get the value of the cosine from the unit circle. Okay, so using our formula, so we're going to use this guy right here, and let me just get rid of all these lines. They're bothering me. And alpha and beta. Okay, so we're going to use that guy. So it's going to look like this. So it's going to be cosine of 45 times cosine of 30 minus sine of 45 times sine of 30. Okay, so what you're going to do now is just look at your unit circle. So cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Remember, it's the x value. Okay, and you'll see, I'll note it right there. Sine of 45 is the same as cosine, so square root of 2 over 2. And sine of 30 is 1/2. And the rest is just simplifying. Okay, so radical 2 times radical 3 is radical 6. 2 times 2 is 4. Minus radical 2 times 1. Oh, my bad. Here, there should be no. Sorry, that's just radical 2 over 2. Okay. Radical 2 times 1 is radical 2. And then 2 times 2 gives us 4 again. So that looks like radical 6 minus radical 2 over 4. Or you'll see it in your book. It's written like this, 1/4 times radical 6 minus radical 2. Okay? So either one of these are totally acceptable. All right, so that's example 1. I'm going to go on to example 2. If you're following along in your book, they don't explain as much in the book, so I hope my video is helping. This is on page 468. It says find the exact value of cosine of pi over 12. Okay, so again, we're going to use our unit circle, and we're going to break up our pi over 12 into some simple, our simple angles. So we know 12. We can use pi over 3, pi over 4, pi over 6. So we're going to figure that out. And it's just breaking up pi over 12. So I used, instead of the book, 3 pi over 12 and 2 pi over 12. So let me just show you what I'm talking about. So cosine of pi over 12 is equal to cosine of 3 pi over 12, which is 1/4, right? Minus 2 pi over 12, which is pi over 6. Okay, so I'm going to simplify that again out loud. I said it out loud, so that's pi over 4, which is one of our easy angles, and pi over 6. Okay, So now we're going to go to our formula, our cosine, and it's our difference, because there's a difference, obviously, subtraction. So it's going to look like this, and then we're using this formula right here. Okay, so where am I? Cosine of, we're going to have cosine of pi over 4 times cosine of pi over 6, and it's plus, I know it's the difference formula, but the this is actually plus. There is a proof in your book if you want to look at it. Go ahead, be my guest, but you don't need it unless you're interested. All right, and then we're going to have sine of pi over 4 times sine of pi over 6. Okay, and again, we're just going to look at the unit circle to get those values. So cosine of pi over 4 is radical 2 over 2. Cosine of pi over 6 is radical 3 over 2. Plus sine of pi over 4. And, you know, I told you guys to memorize these, so I'm just giving you the unit circle as a little guide. It's always nice to kind of look at it visually. Sine of pi over 6 is 1/2. This is very similar to the last one, if you can't tell. So we're going to get, I'm just going to multiply, square root of 2, square root of 3 gives us square root of 6 over 4. And then radical 2 times 1 is radical 2 over 4. So your final answer looks like this, radical 6 plus radical 2 over 4. Or you can say 1/4 times radical 6 plus radical 2. Okay, both acceptable. All right, so that's example 2. Example 3 says find the exact value of sine of 7 pi over 12. Maybe give it a shot yourself and then, you know, hit play and watch the answer. So I broke it up, and I'm going to have 7 sine of 7 pi over 12, and that's going to be equal to sine. So I did 3 pi over 12 because I know that's pi over 4, and 4 pi over 12 because I know that's pi over 3. And you could try it with different angles. As long as it works out to give you 7 pi over 12. All right, so then that gives us sine of pi over 4, and 4 pi over 12 is pi over 3. Okay, so now this is a sine, and this is an addition, so we're going to use this formula right there. Okay, so we're going to have sine of pi over 4 times cosine pi over 3, okay, plus cosine of pi over 4 and times sine of pi over 3. What's crazy is I actually remember doing this, sitting in class and doing this in 11th grade. It's so crazy. It's like coming back to me right now. All right, so sine of pi over 4, again, look at your unit circle. That's radical 2 over 2. Cosine of pi over 3 is 1/2. Cosine of pi over 4, radical 2 over 2. And sine of pi over 3 is radical 3 over 2. Okay, and again, to simplify, we're going to get radical 2 over 4 plus radical 6 over 4. And simplify one more time. So radical 2 plus radical 6, just make it one fraction. Or 1/4 times radical 2 plus radical 6. All very similar answers. Different formulas though. Okay, that's example 3. Example 4 is now giving you, it's still finding the exact value, but notice sine of 80, and these are all degrees, sine of 80, cosine of 20, cosine 80, sine of 20. So that should kind of ring a bell. It's the other half of the formula. So if you go to this part of the formula and find which one you think it's equal to. And if you find it, good job, okay? But it's your sine of your alpha, where are we? There we go. Of your alpha, because see how it's the alpha minus the beta, okay? It's this guy. Because it's 80 and 20, and then 80 and 20 again, okay, in the same order. So that looks like it's going to be sine. So our alpha is going to be our 80, and our betas are 20. okay? So that gives us sine of 60 degrees. And if you look at your unit circle, which I didn't put on this slide, but you can look at your unit circle, it's equal to radical 3 over 2. And just, so I'll go back real quick. So sine of 60, if you take a look right there, there's your sine, radical 3 over 2. Okay? That's example 4. All right, example 5's got a little bit or a lot more going on. Okay, so this is on page, and I did write it down, but it's on page 469. So it's saying sine of theta, I keep saying theta, sine of alpha is 4 over 5, and it's between pi over 2 and pi. So that means we're in, from quadrant 1 to quadrant 2, or quadrant 2, basically. And then this guy is equal to, here's our sine of beta equals that, and we're from between pi and 3 pi over 2. So that tells us where we're going to put an angle, because they didn't give us the actual angle. They gave us the side of the triangle. Okay, so before we can do anything, I'm going to draw a little coordinate plane. Okay, I'm going to do the sine of the alpha, because that's what's given, and I know it's in the second quadrant because of my restrictions here, the pi over 2 and the pi. So it looks like this, and it says the sine is 4 over 5. So we know sine is opposite over hypotenuse. So the 4's there, the 5's there, and you've done this triangle so many times. It's your 3, 4, 5 triangle, but be careful because your x is negative. So this side that was missing is negative 3, okay? And if you can't figure that out, use your Pythagorean theorem. So you could do x squared plus 4 squared equals 5 squared, okay? That's where the 3 came from. All right, so then from here, we also need to figure out, because it asks for, actually no, we can stop right here, because part A is just asking for the cosine of the alpha. So the cosine of the alpha is the adjacent, negative 3, over the hypotenuse, which is 5. Okay? We're going to need this later, so I will revisit that in a minute or two. Okay, because now this is still example 5. This is part B. Now we want the cosine of beta. And again, so we know the beta, they gave us that the sine of beta is between, actually, let me undo that. I want to get some more space here. The sine is the beta is between pi and 3 pi over 2. Okay, so it's in the third quadrant. So it doesn't matter what the angle is. I'm going to make my little reference triangle. There's my beta. I know that the sine of it is negative 2 over radical 5, and I know the sine of beta is opposite, right? Negative 2 over hypotenuse, and it's negative because it's a negative y value, okay? So we have to find that missing side, and I'll use the Pythagorean theorem just so you can see. So we're going to get x squared plus negative 2 squared equals radical 5 squared. We know radical 5 squared is 5, negative 2 squared is 4, so 5 minus 4. So we get, I can't fit it, we get x squared equals 1. So our x is going to be equal to negative 1, okay, because we're square root, but we know it's negative because it's to the left of 0, okay? So the cosine of beta, so here's our beta, our cosine is going to be our adjacent, negative 1, over our hypotenuse, which is radical 5. Please make sure you rationalize, so we're going to get radical 5 over radical 5, and we're going to multiply and get negative radical 5 over 5. Okay, because examples, or part C and D, we're going to use the sum and difference formulas, and we needed these values for those. Okay, so I'm going to turn my notes. You're probably turning your page too. A lot of these take up a lot of space. Okay, so they want us to find the cosine of alpha plus beta. Okay, so we're going to use this formula, and we already know, let me just set this up. Okay, so it's going to look like this. You're going to have cosine of alpha, cosine of beta, minus sine alpha, sine beta. And from the last two examples that we just did, we know the cosine of alpha is negative 3/5. The cosine of beta was negative radical 5 over 5 minus the sine of alpha was 4/5, and the sine of beta was negative 2 radical 5 over 5. Okay. All right, so now let's multiply. So negative 3 times negative radical 5 gives us 3 radical 5 over 25. And then this negative 4 and negative 2 multiplied, that's why it's positive. That's going to give you 8 radical 5 over 25, 5 times 5. And we have like radicals, so 11, 3 plus 8 is 11 radical 5 over 25. Okay, that's part C. And then the last one for this example 5 is part D. And they ask us to find the sine of alpha plus beta. So now we're going to use this guy right here. So it's going to look like, I'm just going to write it so I can replace it right under it. So sine of alpha cosine beta plus cosine alpha sine beta. Okay, so sine of alpha was 4/5. Cosine of beta was negative radical 5 over 5. Cosine of alpha was negative 3/5. Sine of beta was negative 2 radical 5 over 5. Okay, so now again, just multiply. So numerators, I get negative 4 radical 5 over 25. And it's a negative and negative again, so plus 6 radical 5 over 25. Simplify our numerators, we get 2 radical 5 over 25. Okay, that is part D. Okay, the last type of example is with inverse, sine and cosine. Okay, so this is example 9 on page 472, and we're going to find the exact value of all of that. So keep in mind, when you're doing inverse, you're finding the angle measure. You're given the side of the triangle. You're trying to find the angle. So what I'm going to do is I'm going to take these two and make my triangles to help me figure this out. Okay. So this cosine negative 1 is the same thing as saying cosine of, I'll call it alpha because that's our formula. Cosine of alpha equals 1/2. And this is saying sine of beta, because it's a different angle, equals 3/5. Okay, there we go. I fit it. Okay, so they're both in the first quadrant. They didn't say anything else, I don't think. Let me just check. Example 9. Right, they didn't say anything else about this. But we know that we have to limit our inverses. So we're going to stick with the first quadrant because everything's positive. Okay, so I'm going to do 1 and 2. So I'm going to do the cosine first. So I'm going to have my little alpha. Adjacent is 1. Hypotenuse is 2. Let's do the Pythagorean theorem. You might already know it, but you might already know the angle, or I'm sorry, the side. But I'm going to do the Pythagorean theorem. So I'm going to get 1 squared plus y squared equals 2 squared. So I get y squared equals, this is 4 minus 1 gives me 3. So y is radical 3. And then the beta, and I wish I did my arrow better, sorry. There we go. The beta is going to go here. And that's sine, so it's opposite over hypotenuse. Again, it's your 3, 4, 5. You can use the Pythagorean theorem to verify me, but you know, I'm sure you know that that's going to be 4. So that's what that triangle is going to look like. Okay, so now what we're going to do is has now become sine of alpha plus beta. Okay, 2 different angles. And that formula, which you have in your notes, I hope, is sine of alpha cosine beta plus cosine alpha sine beta. I always have to double check because I always mix it up sometimes. All right, so sine of alpha, so I'm going to go to my alpha triangle, so my first triangle. I'm going to go opposite radical 3 over hypotenuse. Okay, cosine of beta is going to be adjacent over hypotenuse. And then cosine of alpha, back to the first triangle, cosine's adjacent over hypotenuse, and sine of beta opposite over hypotenuse. Okay, then it's just a matter of simplifying. So first part, the first two multiplied are going to give you 4 radical 3 over 10 plus 3 over 10, because it's just 1 times 3. And same denominator, that's so nice. So we're going to get 4 radical 3 plus 3 over 10. Okay, and I think, that was it. Okay, so in your book, that was it for the examples. On the last page, page 473, they do give you all of the sum and difference formulas, including tangent, but we're not going over tangent because we haven't talked about verifying anything. That's some stuff that we skipped. So you're not responsible for the tangent, but it's there, so you can take a look if you want to just see what it looks like. You're responsible for the sine and the cosine. All right, that's it. Have a great day.